In this problem, we are provided with two quadratic equations, and the two equations have a common root. Also, it's given here that a, b, and c, these three numbers are in a geometric progression. And we need to show that d over a, e over b, and f over c, these three numbers are in arithmetic progression. So let's begin. So, since we are given that a, b, and c, these three numbers are in geometric progression, so it immediately follows that square of the middle term will be equals to product of the two extremes. So b squared will be equals to ac. So let's label this as equation number 1. Now we consider the first quadratic equation, which is ax squared plus 2bx plus c equals to 0. So let's try to find out the roots of the quadratic equation. So we'll use the standard form. So x will be equals to negative of the coefficient of x, which is 2b, plus or minus square root of, we have 2b whole squared, so that will give us 4b squared minus 4ac, divided by 2 times the coefficient of x squared, 2a. Now we know that b squared is equals to ac as given in equation number 1. So here we will replace the value of b squared with ac. We get negative 2b plus or minus square root of 4ac minus 4ac whole divided by 2a. So this goes to give us the value of x. So x will be equals to negative 2b divided by 2a, or simply x is equals to negative b over a. So we have found out one root. Since it's a quadratic equation, actually the roots are repeating, so it will be negative b over a and negative b over a. As it's already mentioned that the second quadratic equation also has a common root with the first quadratic equation, so we can say that negative b over a is also a root of the quadratic equation dx squared plus 2ex plus f. So let's write it down. The negative b over a is also a root of the quadratic equation given by dx squared plus 2ex, dx squared plus 2ex plus f equals to 0. So that means this root must satisfy the given equation. So in place of x, we can replace it with negative b over a. So that means we have d multiplied to negative b over a whole squared plus 2e times x, so x can be replaced with negative b over a, plus f equals to 0. So let's solve this. So we have d times the negative b over a whole squared will give us b squared over a squared minus 2be over a plus f equals to 0. Now using the fact that b squared equals to ac, so we will replace this value of b squared with ac, which will give us d times ac divided by a squared minus 2. We'll come back to this b in a moment. So we're 2be over a plus f equals to 0. Fine. So here a and a will get cancelled. So we are left with dc over a minus 2be over a plus f equals to 0. So let's divide throughout with c. That means we're dividing each term with c. We're going to get d over a minus 2be over ac plus f over c, that's equals to 0. Now we're going to replace this value of ac with b squared. So we have d over a minus 2 over be divided by b squared plus f over c equals to 0. So rewriting this equation, we'll have d over a minus 2e over b plus f over c equals to 0, or simply 2e over b is equals to d over a plus f over c. This tells us that d over a followed by e over b and then finally f over c, these three numbers are in arithmetic progression, and this is what we were needed to show, hence proved.